Welcome to the 72nd Forest Industry Lecture Series. Our guest today is Dr. Christian Messier, who's a director, basically, Institute of Temperate Forest Science at the University of Quebec. Before I invite Dr. Liefers to introduce him, I would like to mention that this has been one of the longest series and seminars pretty much in North America, I believe. I would like to mention that this is really possible because of generous donations from a various number of institutions, academic as well as non-academic, and then private companies, basically. Now, I would like to list these contributions, donors. We have Alberta Environmental and Sustainable Resource Development, Alberta Forest Product Associations, Alberta Innovates Biosolutions, Alberta Newsprint Company, Alberta Pacific Forest Industries, Altus Geomatics LP, Boreal Management Group, Canadian Forest Products Limited Grand Prairie Sawmill, Canadian Institute of Forestry Rocky Mountain Section, Clifford B. Smith Consulting, College of Alberta Professional Forest Technologists, College of Alberta Professional Foresters, Con A. Dermott Environmental and Forestry Service, Davis LLP, Earth Econ, Foothills Research Institute, 4 Corp Solutions, Forest Soil Science Limited, Foresight Forest Management Specialists, FP Innovations, Greenlink Forestry, Horseshoe Creek Consulting H2C Limited, Incremental Forest Technologies Limited, Jerry Bauer Consulting Limited, Byers Norris Penny, Miller Western Forest Products Limited, Natural Resources Canada, Canadian Forest Service, Philip Robert Enterprises 2010, PricewaterhouseCoopers LLP, Silvocom Limited, Tolco Industries, Wonderwell Contractors 1971 Limited, Watertight Solutions Limited, West Fraser Mills Limited, Weyerhaeuser Edmonton, Woodland Operations Learning Foundations, and Woodlands North. I would like to give a big round of applause for these donors. I would like, Before, I hope your iPad or anything, your calendar, we have a next Fields Lectures on March 5th, 2015. We have a very big name is coming as usual. This is part of the AL's Centennial Celebration. It's going to be Richard Lowe. He's a journalist and author. Some of whom might know that he's the one famous that he wrote the Nature Deficit Disorder. Hopefully March 5th, 2015. Now I would like to introduce Dr. Vic Liefers to introduce our speaker.
Well, it's my pleasure to introduce Christian Messier. Christian is a longtime colleague and friend. He's been in this province, I think, for 10 years out of the last 20 years of his career. He's a professor of forest ecology at the University of Quebec in Montreal. And he got his bachelor's degree from University Laval and his master's in forest ecology from University Laval. And then he moved to UBC, got his PhD there. He did postdoc work in Helsinki and then back at Laval. And he's been at University of Quebec in Montreal for more than 20 years now. So as I say, I've known him for more than 20 years, and he's always been, after his completion of his PhD and his time at the University of British Columbia with Hamish Kimmins. We worked together on sustainable forest management for about 10 years, and this was leading from Christian's work with light. He was an ecologist, a standard ecologist, just like I was at that time. We were studying light. He and other things in the forest, other things like regeneration. Christian then, as he started to mature, just like most good scientists, and I put him in this category for sure, he started to look at bigger picture things, and he started to do more modeling. And he's developed conceptual and mathematical models, and this work and his ideas that are associated with these models has stimulated all kinds of new ideas and sometimes very controversial ideas. Christian is not afraid of controversy, and it takes a bit of courage to do that, to be controversial, and so Christian has that. So I hope that we'll see some of that controversial stuff that's going to make people mad today, like he's quite capable of doing. He's published 170 research papers in his life. Most of these are with students and colleagues, and I'm one of the colleagues that he's actually published some of the work, and we've other colleagues in this department that are in our department who've worked with Christian. He's written some books recently, and I think these books are going to play some role in his talk today. Critique of Silviculture, Managing for Complexity, and a very interesting book, and that's takes a little different look at silviculture, the way it's operating, and the nature all around us, and managing forests and complex adaptive systems. And I expect that you're going to see this come through in his talk today on forest management to stewardship, viewing forest as complex adaptive systems in an uncertain world. So that's his title, and I expect that you'll be stimulated, and I hope he'll live up to his normal controversial self and say something that gets my steam rolling.
Yes, now it's working. Well, thank you very much, Vic, for this, I don't know, you set me up for failure, I guess, so thank you very much. Of course, it's a pleasure to be here. Every time I come to Edmonton, I feel at home because I spend almost, as Vic said, almost 10 years of my life coming here, according to my wife, way too often. She was kind of starting to wonder if I had other interests than forests when I was coming to Edmonton. But no, I reassured her, and I think now she feels okay. It was not the case. I came here only to see the very good people in Alberta and to work on trying to develop a new way of managing the forest in Canada. And these 10 years with the Sustainable Forest Management Network has been among the best years of my career. And I often say that they has actually formed me and trained me. So I like to say that I am the way I am today because, in large part, the good and the bad that we had to go through in the SFMN. So thank you very much, everybody, for this. So now I have a task, if I understand correctly, is to make people upset. And I've done that regularly. But it's not because I'm brave. I think it's because I'm stupid. That's what my kids tells me, because they say, why do you want to make people upset at you and all of this? And I don't see any reason. I think the main reason is I tend to say what I think, and a lot of the things that I think, people don't agree with, which I think is okay and is a good characteristic of a professor. If the professors say everything that people agree with, it's kind of boring. So you need to provoke a little bit. So Vic mentioned University of Quebec in Montreal. I've been there for 20 years. I'm still there half-time, but actually in the last 2 years, I have accepted a position at the University of Quebec in Outaouais, which is, Gatineau is right here, and this is Ottawa, just to make sure. This is a little university, very small, 6,000 students, not 200 or 300 professors, and because the university and with some local people were successful in convincing the provincial government to put $11 million into developing a new institute in temperate forest, research in temperate forest and enough money to hire around 15 new researchers that will be professors and develop a new science department at University of Quebec in Outaouais. And then the center is not actually in the city, it's right in the middle of nowhere in a small town called Ripon. You may not have heard of it, but since I've been moving there, you will hear about it. I mean, I will try to make sure you hear about it. It's right there. And the nice thing is that we were able to buy a beautiful piece of land near a lake and a house, and this was a dream. So this takes half of my time, and my duty is really to help hiring new people and help them develop their career and try to develop an institute that will try to make changes in the way we manage the temperate deciduous forest. Okay, so I will talk a bit about forests and try to convince you that a forest is a complex system. And I will explain what a complex system means. And I will try to explain to you why this is a complex system and even that are adaptive and why we should care about it. I think this is an important concept. And I came across around 10 years ago, and I have been thinking a lot about it, written a lot about it, and I think I see this as a very nice way to move forward and to do a better job at managing the forest in the face of these very, very changing time. And I think this is where this concept is actually very interesting. I like this phrase. I think it was Yogi, what's his name, Berra, that was a baseball player, says that the future is not like it used to be. And I think that applies very well. I'm not sure what he meant when he said that, but when I read it today, it's quite clear. As foresters, we used to think that the future was like the past and that we could actually quite be certain that in 100 years there will be a certain condition. And I think now we know that it will be very different. So this is something we'll talk a bit about. Then this is something I've tried to do. I was a forester, trained as a forester, but then moved into a biology department working with ecologists. And I'll try to talk a bit about the need to reconcile ecology and forestry. Still today, I'm amazed of this, but we have scientific meetings for forestry people and we have scientific meetings for ecology people, and we don't mix very much. And I try to go to both and piss people on both sides. That's actually what I like to do. But now I'm trying to reconcile the two, and this is actually, I don't know if you know, but this is a nice book in French called The Man Who Planted Trees. It's a beautiful book. I read it regularly because it makes me continue working and trying to promote forests and trees in the world. Then I'll move into really the main talk, complex adaptive system, and something that I will try to convince you could be a framework for the novel practices that we need to develop in the future to make the forest more resilient and more able to adapt to all of the crazy things we do in this planet. So I think if we were not changing the planet so quickly, maybe we will not need to do things differently. But because we are affecting the planet so quickly, I think we need to be more proactive. And then, of course, I will try to tell you some ideas about maybe what could be done and how we could do it in some conclusion. Actually, I will spend a lot of time on the conclusions. Okay, so forests are a complex system. And I know most of you will agree with this, but you know, trees and stems are linked in so many ways. We are talking about networks, lots of work in ecology about networks and food webs. Here's a little roots with mycorrhiza, and I really like this work of Suzanne Simard. She's a forest ecologist at UBC. And these circles are actually Douglas fir trees of different size, different age, and these links are showing how these trees are linked through mycorrhizal network, exchanging nutrients, exchanging energy, and probably also exchanging informations. And you could analyze actually a stand like this not as individual trees, but as a network of trees that are highly connected, and some that are more connected than others, like this one, which may actually play a more important role than the other species. So it's kind of a different way to look at forests. And I will tell you that more and more I am interested in looking at trees and plants not as competitors, but as facilitators and as organisms that actually help each other. And if there are some people in evolution here, it will kind of make sense. Imagine that you've evolved for 300 million years growing with neighbors, and you cannot move away. Will you keep fighting them? I mean, you will develop some kind of understanding that, okay, I give you this, you give me this, and if it's a bad time, maybe I'll help you, vice versa. There has to be like this. You cannot just keep fighting. So I think, and we know now that there's been a lot of co-evolution, a lot of facilitation, and more papers are coming out of this, and I think it's a bit of changing the way we look at the forest. And this was actually a chapter in this latest book that we published, if you are interested. Very nice chapter on meta-network of fungi, fauna, and flora as agent of complex adaptive system. Of course, in Quebec, actually now we have the spruce budworm is back. This little bug is starting to kill trees, which is neat, because as the epidemic in the West is decreasing now, we are having trees that are being killed, so we'll be able to flood the market with cheap wood like BC has done for many years. It's our turn. So you have a simple forest, mainly conifers and balsam fir, and you have a kind of ugly-looking little bug, I'm sorry, and a very simple relationship, right? No, of course no. And this is a paper that came out in 2007 that shows the tree, the bug, and some of the other elements that are interacting to make the epidemic increase or decrease. Some of the elements. So this is a very complex network. It looks very simple, very complex. And this is only at one scale. You can go at higher scales or lower scales, and then you start realizing it is complex indeed. Okay. And we can look at the boreal forest at the stand, and this is actually a chapter from Phil Burton in this book, very good chapter, Exploring Complexity in Boreal Forest. A lot of people will say the boreal forest is simple, few species. We know now with the spruce budworm that it's not so simple. And if you have a stand like this, let's say black spruce, and if you cut it or if there's a fires, now we know that depending on the initial conditions, the previous disturbance, some chance factor, a dry summer or a wet summer or a cold winter, whatever, you could have all kind of pathways that are very hard to predict. So these are all elements of complex adaptive system, and starting to build that with you. But in Phil's paper chapter, actually, he does a very good job at demonstrating that even a boring boreal forest is extremely complex, but not the same complex than a tropical forest. We have Robin Chasden also, she wrote a chapter about the tropical forest. And I think it's clear that we cannot say one is more complex than the other. One has more species maybe, but not necessarily in terms of complexity. I don't have a paper. Yeah, I do have yeah, thank you. I wanted a paper. Because I do that in my class when I show about a complex system. I take a little piece of paper, and you see this is a little piece of paper, and if I drop it, I have no idea where it will go. And let's say I take another piece of paper, same, it's not the same, but if it was the same, it will go another way. So this is a complex system. And physics people will say this is a complex system. Because every time that I put the paper, I don't put it at the same position, and because of all the physical interactions that are not linear, a tiny little difference will make a big difference in the direction. And there's been a lot of interesting papers on this, and this is not living, and it's extremely simple, and we cannot even predict where it will go. Okay, so the future is not like it used to be. I will go quickly on this because we know about climate change. I think we know climate change. We know about invasive species. This is a graph showing how the species are moving. We have more and more species. I will say here you have been maybe isolated. I'm not sure why. I brought a few species with me on my trip, but In the east, it seems, I calculate that almost every 10 years there is a new bug or a new fungi that comes and threatens a species. Now we have the emerald ash borer, we had the fungi that is killing the beech, we have a bug that is coming from the south that will kill the hemlock, and we have the Asian longhorn that is hiding in Toronto and some places that are killing the maple, and et cetera, et cetera. I've talked to entomologists and pathologists, and there's many of these species, and there's a lot of uncertainty. And since we are trading with who? The two worst places in the world for us. We're trading with Asia and Europe, the two places where the forest has the same genius, same climate. It's like we did that on purpose. We said, well, where could we go where we will increase the chance that we'll have invading species? And I mean, it's crazy. We should trade with Brazil and with Congo, not with China and North America, Europe. It makes no sense. I've tried to convince my politician to change, but I haven't been very successful, as you can imagine. So there's also this ability to intervene, economical constraint. We are in the middle of economical constraint, but now I know that it's not true. We are, for the rest of my life, will be in economical constraint. That's kind of normal. Social constraint. People seem to be more and more difficult to know what they want, and very, very difficult to satisfy people. And ecological constraint. These environmentalists and these ecologists that come up with all kind of new reasons why we cannot cut a tree the way we want to do it. But this won't go away. It will increase. So we have more constraint. And of course, the market, new products are emerging, forests are being perceived very differently. Using wood for energy, using wood for storing carbon. I mean, things are changing more and more quickly, so how could we do like we used to do? And I talked in a class this morning of Marty Luker about how crazy it is to do sustained yield and plant a forest like if we will cut the same tree in 150 years like we do in Quebec. It's still part of the law. We cut according to a strategy that will say that in 150 years we should be able to cut the same species at the same volume. Isn't that crazy? Isn't that totally stupid? We still do it. I don't know. Okay. So, and all of this, I don't know, you've probably heard about these novel ecosystems. I was told by Richard Hobbs that he had a very hard time to publish his first paper because he kept rejected. But the first one has been cited, I think, more than 3,000 times now. But the idea is that, let's say in the past we had certain ecosystem. We have modified the environmental conditions, climate change, acid rain, all of the things. And then we have more and more species coming from abroad. So we have changed. So now we are in what we call systems that have no equivalent. Totally different system. So we are in novel ecosystem. And so basing forest practices on past natural or managed conditions are actually quite risky because the system is not the same as it was before. And in the future, it will be very, very different. And I was at a radio station this summer to try to explain to people the fact that all the earthworms that we have in eastern Canada are not native. Because there was a program that wanted to convince people how wonderful they were. Well, maybe in your garden, but in the forest, they actually, now we're starting to realize that they are really threatening a lot of understory plants. And it's everywhere. So, I mean, we are in the novel ecosystem, and it's changing more and more. And in my province, and I suppose in Alberta, and I'm guilty of this because this was one of the objectives of the Sustainable Management Network, was to develop ways to emulate natural disturbance and bring the forest like it was before. And now I think it's risky. And I think this is the law in Quebec. And I know that it took 20 years to change the law in Quebec to bring it to this level of emulating natural disturbance. And just when the law was passed, I told them, wait, we are wrong. I didn't make a lot of friends. Okay. So reconciling forestry and ecology. I work a lot with ecologists. They are not necessarily forest ecologists, with a lot of ecologists. And this fellow, Lauro, he's a French scientist. He was at McGill for many years. He went back to France, but worked a lot on this relationship between biodiversity and ecosystem processes. And he has this book. And he kind of, I like to summarize the book like this. He kind of says that in the natural world, you have, if you look at the natural level as being here, you have relationship between biodiversity or complexity, I added this, and ecosystem processes, service, or resilience that are like this. Either like this, linear, idiosyncratic, you reduce biodiversity and you may have more service or less, or keystone, you remove one species and it collapses. So guess what we did in forestry? Which one of these do you think we assume was the case in the forest? If I was in a class, I will listen to you, but I will move. Of course, this is this one. We assume we can take a natural forest with a lot of species, a lot of structure, we can simplify it a lot and it will have almost no impact. This is how forestry was developed. I like to blame the German. Germans don't like messy things. They like things that are neat and clean and orderly. So they thought, nature doesn't know how to produce timber properly. We do. So we'll make it more simple. And they were so good and stubborn that they spread all over the world. And now people even try that in the tropics. Can you imagine trying to do that in the tropics? So this is what was assumed. And now just a few papers. This is from Spain, where they look at the number of species and the wood production using permanent plots. Very clearly, the results show that the more species you have in a plot, the more wood production you will have on average. Same thing here in Sweden. They look at different things. Maybe you don't see, but this is wood, this is blueberry, this is games. There's different things. And this is the number of tree species. And sometimes it goes up and down, but there's a trend. The more species you have, the more chance you have more services. And we did also a study in Quebec using our permanent plots, using this very interesting mathematical or statistical model. And then we isolate a very strong correlation or relationship between functional diversity and productivity. And more recently, in ecology letters, it shows that forest productivity, the stability of the forest productivity increased with tree diversity. So it's not just the productivity, but the stability, which makes sense. If you have many species, you have a dry year, some species are better, so some will grow less, some will grow more, and maybe some will help the other ones that have more difficulties. So there is actually a lot of benefits. So I think I'm always asked, so why do we still promote simplifying forests? I still see that in forestry. I still see when I talk to foresters, maybe not in Alberta, I'm sure you're different in Alberta. Please tell me that after my talk that you don't want to simplify the forest anymore. You realize that the worst thing you should do is simplifying the forest. And I will say I came here for nothing, but that's okay. At least I've seen some good friends. And I still wonder why we do monocultures in plantations. I've checked recently, I think 99% of all plantations in the world are monocultures. Why? Are we so simple-minded that we cannot think that we can plant 2 trees? And we look in the forest and see how the forest is doing it. They often don't do this that way anyway. So these are some questions. And if you look at this Millennium Assessment, you know, all the ecosystem services and all the good things that it does, they have put that biodiversity in very clearly. In most of the studies, they show that you get wood, maybe more wood or more regular wood production, so less fluctuation, more fresh water, more chemicals, more habitat, more recreation, if you maintain biodiversity. So biodiversity is very important. We're starting to know this. And this comes from a lot of studies done in ecology, not just in the forest, in grassland, in lakes, in ocean. And here I like this. This is in Spain. Of course, Spain is not a big wood producers, but they've came up with the fact that the forest, in terms of value, is only 35% of the value of the forest is in wood. It's in carbon, water, hunting, recreation, non-woody forest products, grazing, etc. And I think they are trying to put a value in all of these other things. I think if we do the same thing, we'll have some interesting results. And I had a meeting, a little workshop I organized. I invited David Lindemeyer, who is a quite well-known scientist from Australia. And he was telling me about a forest north of Melbourne that foresters want to cut, and that where they have calculated the maximum yield of cutting the wood. And he feels, and I'm not sure if he's right, but he feels that this threatens some of the quality of the water that feeds Melbourne. And they calculated that if they didn't have this watershed with clean water, it would cost $2 billion a year to produce clean water. So this 100,000 hectare watershed produced for $2,000 of water per year. So why are we still managing as if wood was the only or main products? I had the chief foresters at my meeting last week, and I asked him the same question. Why are you putting wood? Why do you calculate how much wood we can cut and all the rest are constrained? There's less and less evidence that this is the best way to go. You should look at all the values, and we have the tools, we have the models, and try to see according to the current conditions and the possible future condition. Carbon value is low now, but I'm quite certain that in 50 years we'll put much more higher value in carbon. So what kind of management could increase the carbon? What kind of management? Water is rare. Any management that preserves water. And in some cases, and I'm working with some students on this, in some cases, it does not mean that you should not do forestry. Forestry can be compatible in some cases, but it may need to do a bit different in forestry and not assume, like we did a long time, that if we grow trees, everything else will be okay. And again, biodiversity is key. I was told I had a lot of time, but I tend to talk a lot also. Okay, complex adaptive system. Oops, sorry. I'll try to explain what it is. It's quite simple. It's any system that has a diversity of agents or elements, different trees, different bacteria, different humans, different whatever, hockey players. I usually bring a hockey players because a good team, I have to talk a bit about hockey, but you know the New York Rangers, they used to, before there was this top in terms of salary, they used to hire always the best players and never won anything, because they didn't understand what was a complex adaptive system. Because a complex adaptive system means that you have to have different players that do different things that kind of complement each other. You don't just buy the best, but if they do the same thing, they compete, and then there's no gain in it. So a diversity of agent or elements which are connected with certain behavior or relationship and actions which are interdependent. This is very important. A group of chairs here, even if they are different colors, this is not a dynamic system. It's not, there's many agents, they have different colors, but there's no interaction. So that's actually very important. And they exhibit adaptation and self-organization, and a forest is it's a perfect system. We published a paper in Ecosphere recently about this, how forests are almost the perfect complex adaptive system. And here are three characteristics that are interesting and important, and we'll talk a lot, is that a system like that is inherently somewhat unpredictable. When my kids were a bit younger, like teenagers, I would say like my kids, like a teenager. Now they've grown, they become a bit more predictable. And the other thing that's interesting is that they produce emergent phenomenon. In the complexity parlance, it means that when we look at the elements, we cannot predict what will happen at a higher scale. There will be some emergent properties. And it can change and adapt to novel conditions, and this is the most important. This is what we want. We want a system that can change and adapt to novel conditions. Why? Because we are facing a world where there will be rapid change. So much so that we would like to leave systems that can change and adapt without too much of our interventions. Because we could go and plant new trees and new species and and change the composition as climate change or new species arrive, but it would cost a lot of money, and we don't have a lot of money. So we need to design forests or leave forests after we go and harvest it that can change and adapt to the novel conditions, some of them that we know, but many that we don't know. But I'll come back to this. And here I want to talk about 7 properties of this complex adaptive system. It's a chapter by Lyle Parrott and this fellow Lange. I mean, they are complexity specialists, and we asked them to write a chapter about what is a complex system in a forest. So this is what they said. They say a complex system has these 7 properties. Openness. So it's the capacity of a system to exchange energy, material, or information with the external environment. A forest does that. It exchanges. Deers pass through, wind, there's fires coming, there is logging, we took the wood out. So there's a lot of exchange, and I put fire here, and I put a paper by Robin who talks about how tropical forests will recover following some kind of natural disturbance or human impact, depending on what are these impacts and how are these disturbance, because the forest is open. And when I look at forestry, I think we've often assumed that the forest was not open, that we can intervene and come back in 50 years and predict what the forest will be, because there will be no interaction with the world, and we know it's not true. Heterogeneity and biodiversity, I will go very quickly. I'm sure you know this is true. Lots of biodiversity, lots of heterogeneity at different scales. Even the simplest forest is extremely complex. Hierarchy. Almost in any forest, you can go from a mycorrhizal network, pathogen network, forest stand network, to forest landscape network. And all these networks are interacting against each other and creating a fairly complex system. And lots of papers, I just choose a few in Journal of Ecology, about hierarchical response of plant-soil interaction to climate change. So they really look at different scales. Widespread crown condition decline in the food web, amplified tree mortality with climate change. And now we know. I mean, we know a tree dies, a lot of things happen at the lower scales and a lot of things happen at the higher scales, and it explains why the tree is dying. So I think this is quite obvious today. Self-organization, very interesting paper by Simon Levine. If you have never read him, you should read this paper, Self-Organization and the Emergence of Complexity. This was an important paper for me. When I read this, I could say that some people will say that I went into the dark side of the forest. I've been told that. Or that I saw the light. It depends, you know. But this was actually a very interesting paper that shows that these complex systems have a self-organization and they can adapt. That was important. And this funny-looking flat 8, we can call it, which comes from this book by Gunderson and Halling called Panarchy. It's too bad that he used a name like this, because I remember the first time I saw the book, I said, why would I want to read a book called Panarchy? I had no idea what it was, but anyway. Finally, I read it, and it kind of makes sense. It shows how a complex system have the ability to reorganize in the face of external perturbation so that they maintain their functions. And this is actually what we want. I will say, and I would like to argue, that if we have a forest, I don't care which species will grow later on. I don't care. I don't care what will be the structure distribution. What I want is that it keeps the same function and that I have the same service from this forest. And so I want a forest that can take more and more of these stress and be able to reorganize itself and continue to provide the goods and services that we need. Water, carbon, wood, of course, biodiversity, habitats. And there's more and more of these papers about resilience. Resilience is the kind of the end result of adaptation. A forest that adapts very well is a forest that is resilient. Lots of papers about how to make the forest resilient, so much so that we're starting to talk about a forestry for resilience. And finally, memory. Forests have memories, long-lasting influence caused by past events or legacies. And I think we know this. This is a paper from Spain, but it's kind of interesting. People are looking at if a fire arrives in the stand will behave very differently depending on what was the previous history of the stand. We know this. A stand has a memory. It remembers in the soil, in the humus, in terms of the organism, etc. And this is very important because a tiny little difference in the initial conditions, because of the non-linearity of a lot of the relationship, means that after a few years, you can have a system going in very, very different directions. So this is another important. And the last one, and maybe the most important, is uncertainty, the inability to make exact prediction about the state of the system. It took me a while to understand that even if I do more research and I develop better models, I will always be unable to make exact prediction about the state of almost any system. You can continue if you want. You will never be able to, for two reasons. Because a lot of processes are inherently stochastic, and because of this, maybe more important, what people call deterministic chaos, which only means that when you have a tiny bit of differences in the initial condition, because of the nonlinear relationship, very quickly the system will go in a different direction. If you can make a little program, you can play with this, you change a bit the initial condition, you make relationships that are nonlinear, and you will see it will go in all kind of directions. And this is true in most of our forests. So this is a very important characteristic, and a very wise man from the United States explained it very clearly. And this is actually this guy, Donald Rumsfeld, extremely bright. And he said, when a journalist asked him why there was no weapons of mass destruction, in his philosophical way of thinking, he says, well, we know there are no known knowns. So we know that if we invade Iraq, we will win. That we know, right? There are known unknowns. So so we know a lot of things we don't know. We don't know how long it will take us. We don't know how much money we'll spend. And he said, but there's also the unknown unknowns. And this has, I mean, in all complexity, people, they use this because this is clever. This is reality. And basically what he wanted to say, he says, don't bother me, I don't want to talk to you. But this is true. This is easy, we deal with it. This is also relatively easy. We know with climate change it will get drier. We know we have some species, but the unknown unknowns are difficult, right? And he wrote a book, actually, because we made a lot of fun. He wrote a book that he calls The Unknown Known. I haven't read it. I want to read it, but I thought it was good of him to respond to it. But because of the unknown unknowns, we have to be very careful, because we know there will be surprises. Anyway, I like to make fun of him. I could have selected other people, but anyway. And in this book, we have, in the book that we just wrote, we have a chapter where we try to play with these, what I call these 10 fairly innovative forest management practices that are coming in the world, close to nature in Europe, systematic silviculture in Italy, ecosystem management that we do in Quebec and many other places, mixed plantation, variable retention, reduced impact logging in the tropics, continuous cover, new forestry, integrated forest management, and uneven age. These are all different practices that we tend to do to protect biodiversity. And we discuss among us, are they recognizing each of these 7 properties: openness, heterogeneity, diversity, hierarchy, cross-scale interaction, memory, self-organization with emergence as consequences, uncertainty because of non-linearity, and adaptation. What do you think? Is there one that you think take all of this into consideration or not at all? I mean, I don't know if someone wants to try. No? Vic? Okay. Well, we look at it, and when it's dark, it means that we feel that it takes this well into consideration in the practices. When it's gray, we thought in between, and when it's white, not at all. And I try it with many people. We don't all agree. But basically, a lot of these new practices, it's quite clear, deals with heterogeneity and diversity. This is what we've done better in the last 10 years. And there's no doubt about it. And biological legacy also. I mean, it's variable retention. A lot of these close to nature is leaving legacy so that the forest will be able to come back with more biodiversity than before. This is quite good. Openness, a little bit, but not too much. We don't really look at what could happen from the outside because we don't really know. Hierarchy and cross-scale, some of it do it very well, some don't do it very well. Self-organization, again, not so bad, but the big problem is here, uncertainty. We don't like uncertainty. We don't want to deal with it. We don't want to think about it. And adaptation, we think a bit about it, but not too much. So I think this was kind of a guideline that says, okay, there's practices that are good, but maybe we should, that was the recommendation. In each place where you do these practices, try to see how you could bring more openness, more uncertainty, more adaptation into your system. And I think all these systems could be very good. So this was the idea behind this little exercise. And if you ask me, because I've been asked, but how do we characterize a complex system? This is a hard question. And Lyle Parrott, she was at the University of Montreal, but she left for UBC, and now she's in Kootenays working there. But she's written a nice paper that shows that a complex system, and here is some measure of complex system. The measure is the amount of information you need to describe a system. So if you need an infinite amount of information to describe a system, you have something that is totally disordered. If you need very, very little information to describe a system, you have something that is very orderly. And if you're in between, you are talking more about a complex system. So you can present it in these kind of patterns of dots, or in these networks, or in these, I'm not sure how you call this, but these frequencies over time. So you can have different patterns, and then you can detect when a system is complex. So that can be useful, especially that if you look at a forest, this is a plantation. Of course, a plantation is orderly, for sure. And if you look at almost any forest after a big fire or a big clear cut, it's fairly messy or disorderly. But if you leave time, what does nature do when you leave a plantations or a forest after a clear cut? It moves into the middle portions. There is a force, it's part of nature, to become complex. It's so much true that there is a very nice little book called Simply Complexity that says that we find that in the literature and the music. And here's another test, because I like tests. I'm a professor. I like tests. So I don't know, this is in French, but this used to be very popular. You know these Harlequin books that we all read? I've read one because I was curious. If I look at this book and I say, when I read this book, do you think this is something that is more totally random, very orderly, or a complex book? Where will you put it? Well, clearly it's there, because once you've read one, you don't need to read the other one. It's all the same. They change the size, the length of the hair, or some are in Florence, some are, but it's all the same. So it's very orderly. And of course, if you take a random generator and use letters, that's what you will get. But they analyze these books like this one, Tolstoy, War and Peace, and they analyze the word, the structure, the way the novel is constructed, and they came up with a description that is actually in between. And they even go as far as saying that our brain is geared to complexity because these books, we tend to read it again and again. They become classics. We never get bored of these books. This, you know, and this, well, we don't do. And it's the same with music, you know, the dance music, the disco, and da-da-da. It's quite fun, but do you have a music that you listened 20 years ago, disco, that you still listen every day when you go in your car? You're tired of it. And of course, if you do something totally at random, You won't even listen to it because it's not nice. Beautiful music, classical music, has a complex pattern. And the book goes on many examples. I was flabbergasted, I like this word, when I read this. It was incredible. And so much so that I even wrote in my first book about critique of silviculture, managing complexity. I looked at my teenager at that time and I said, wow, these are complex systems. And I have a little, go and read it, it's quite fun. My wife cried when she read that because she said, you explain our kids so well. It was wonderful. Anyway, the little message is that if you take a kid and you control it, push it, try to make it go in a certain way, what will it do? It will rebel and probably do something terrible. But if you nurture it, give them a lot of opportunities, it will not become the doctor or the lawyer, but it will do something good and useful and quite interesting. So that's like complex system, like a forest. If you push it to go in one direction, you will have to work very hard. You have to repair. But if you give it all the ingredients to evolve, it will not give you maybe the white spruce stands that you need, but who cares? Because in 40 years, who knows what you will be needing? But it will give you a functional forest. That's the key. Okay, and we played with this concept and we put these different systems along this description like monospecific plantation, uneven age management, ecosystem management, unregulated exploitation, systemic forestry in Italy. It's quite interesting. And what we are saying is we should move this there and move these there and maybe try to develop this kind of a complex adaptive system. So that's a bit of an idea we came up with. So what to do in some conclusion? Am I okay? I still have a few minutes. Because this is a book that just got accepted in conservation letters. I phoned Simon Levine 2 years ago and I said, Simon, you don't know me, but I'd like to write a paper with you because if I write a paper with you, they will take me seriously. And he said, yes. Amazing. He said, yes. And he said, I will come to Montreal because his wife is from Montreal. I didn't know that. And he even told me, and he doesn't work in the forest, but he says, I understood complexity when I was young, when I was in the forest. And I said, Simon, wow. So anyway, we wrote this paper with a lot of other people, Stewardship of Forests as Complex Adaptive System. This is the title of my talk. This will be coming out. And we came up with what to do. We need to replace the sustained single good or objective yield paradigm with one that integrates risk, flexibility, adaptability into scenarios of sustained provision of various goods and services. This is what we need to do. I'll explain that more. We have to consider both the taxonomic and functional tree diversity. This is big in ecology right now. You can have two species that do exactly the same thing. This is not a high diversity, but if you have two species that are very different, then you have a higher diversity. So the functional diversity is important. We need redundancy also in the system so that we will provide good and service in a changing environment. We don't know which species will do the best in the future. We don't know what combination will do the best, so let's try to have as many combinations as possible. We need to promote an optimal balance among modularity, and Simon actually worked quite a bit on this, is an extent to which a system can be divided into independent units. We talk a lot about connectivity, it's very important, but if you have a system that is too connected, when there's a fire, when there's an insect, it will spread. So you need both connectivity and modularity in your system. So when you work in the forest, you should always think of, I want forest be well connected, but different structure, different species, so that any disease or any problem will not be able to spread too easily. We want to plan and intervene across scales, spatial and temporal scales. This is quite obvious. We want to develop long-term scenario using these new tools. There are tools now that can deal with uncertainty. And there was this paper that I came up that I found interesting, scenario planning. We tried to do that with the SFMN. There was Peter Dunker that developed, he's supposed to write a book. I haven't seen it yet. I keep bugging him, but he's supposed to come up with a book. But this is kind of interesting. They show that if you have a system that you can control and where uncertainty is very high, you have to do adaptive management. You need to try things and you see if it works and you adapt it. But if you have like a system you cannot control, like a park, well, you need to do scenario planning like this, where you look at almost what are the worst case scenario according to different axes, and you try to develop a strategy that can deal okay with all of these scenarios, the unknown unknown or known unknowns. This is actually quite interesting, and you can do that on a piece of paper. And maybe I will do a bit of a publicity, but Klaus Putman, my colleague in crime, and I and Lyle Parrots, we are organizing a summer school in Oregon this next year in June for a week. And I will send you the advertisement, but we want to bring people, we'll do exercise, how we do this. We've been thinking quite a bit about this, and we have had some experiments. We've used it with our students. It seems to work. So we want to increase the involvement of local communities and other stakeholders to ensure that future forests are better aligned with the needs of the preference local people. This doesn't come from me, but we had a social scientist in the group, and he convinced us that this was very important. And we want to allow and encourage the social environmental system to self-organize and to adapt to novel biological, environmental, and social conditions. And here I have a good example. We were invited in Japan 6 or 7 years ago because Japan has a big problem. After the Second World War, a lot of their forest was destroyed or in poor conditions, so they started to plant. Big program of plantations. Where did they look for how to plant? Unfortunately, they looked toward Germany or the classical forestry, so they planted monocultures. They say, we'll plant trees, and in 50 or 60 years, we'll harvest them to feed our industry. What do they do today? They don't harvest these forests because it costs too much. The labor is too high. They take cheap wood from Russia, maybe even from Canada, I'm not sure, or other places. So they have millions of hectares of plantations that are getting old, that are not regenerating well, that are collapsing, and they have no money to manage these forests. And this is a clear example of they didn't consider that how will the system self-organize and adapt if the social conditions change, the environmental conditions change, or the biological condition. And I think that's what we should do. It will change. Another good example, when I was at UBC doing my PhD, we spent millions of dollars killing red alder to make Douglas fir grow better. Red alder is a beautiful tree. It fixes nitrogen for free. Great habitat for many species. We kill it because there was no value. And something like 5 or 6, 7 years ago, I don't remember who, but someone developed a market in Europe. There's a big market for red alder, and the value of red alder is as high as Douglas fir. And there's many examples like this. So, what to do? And this is, I came very complicated, and I tried to make it simple, but we need to modify the current regulation and law to redefine the concept of sustainability in light of uncertain and rapidly changing future conditions. Sustained yield makes no sense. There's a lot of things that make no sense. We should redefine it totally in the light of this uncertainty. And what is sustainable should not be one species or one fiber. It should be a group of values. And we have to consider the future conditions. And this is a paper that just came out. I like it, The End of Sustainability. And they argue that sustainability is, what's the word for this? It's kind of a trap. We'll get trapped into this because we want to maintain things the way they are. But I think this morning, in Marty's class, we came up with, what was it? Changing sustainability or dynamic sustainability or something like that. But we need to change the term because they say we must face the impossibility of defining, let alone pursuing, a goal of sustainability in a world characterized by such extreme complexity, radical uncertainty, and lack of stationarity. I mean, I see that. I accept that. So we need to broaden the stakeholder base in decision making so that we consider all of these goods and services. We talk about it. We need to monitor much more than just wood, all the ecosystem service, and promote markets that will put a value into the other services and goods. And I think lots of work are being done on this. It's coming. It's coming. We will put a value on water, we'll put a value on carbon, we'll put a value on pollination. Then we can make a modelization and see this is how we should maybe manage the forest so we can get the most out of all of this. So this is another important aspect. And modernize economic approach to better reflect risk and diversity in forest products to reduce the reliance on single species. I'm sure Vic Adamovich will give me a hard time. He will say, we already do this, probably, but then we should implement it. And I've been working with an economist on these, how do you call it, the real options. And I know that in some field they are using real option, and real option is an interesting way to look at, I don't want to maximize the profit under the current condition, but I want to look at what could make the more profit in the future if the conditions are changing also. And we know they will be changing. So there are ways to look at this. And to integrate risk and uncertainty in management prescription. Absolutely essential because of all the reasons I told you. So this is the end. This is, I think, my last slide. I think we need to re-educate. So this is the people older than 35, means me. And we need to educate maybe differently the foresters. Maybe you already do it. You will tell me. But this is, to me, the evolution of forestry as I see it. And I tried to find a name on the plane last night. I was late. I call it steady state simplification-based forestry. So that was the forestry we've done so far. We considered there was steady state. We tried to simplify it. Single equilibrium. We reduce diversity, variability, heterogeneity. We prevent disturbance, fire, insects. All this are bad. And we maximize the yield of wood of only a few tree species. So this is my new name for the German forestry as we know it and as we still practice it in many parts of the world. And I think we are moving slowly toward what I call a dynamic past ecosystem-based forestry. Is where we now have multiple historical states. Historical because we look in the past. We say our nature knows, we should look in the past. We encourage diversity, variability, heterogeneity, but past heterogeneity. We don't want it to make different than what they are. We accept disturbance, and we maximize sustained yield of wood with constraint. The constraint being often biodiversity, water quality, all these things, not the value of the water. And I think I would like this to be on the same level as the wood. And I think we are, and what I propose, we should move into what I call a dynamic complexity-based forestry. Which means that we have, now we know we have multiple novel states in the future. The forest will not be the same. We don't even know where it will go, but we acknowledge that it will be different. And to maintain a forest that is functional and adaptable, we need to foster diversity, variability, and heterogeneity, maybe even beyond the historical species pool and diversity that we have. And I know when I say this, some people get very nervous, but we have to fight fires with fires. We've changed the ecosystem so much. We are continuing to change it so much. And we say, let's rely on what nature has provided us to deal with this incredible complexity of changes that are occurring in the future. And I think we need to be careful, we need to be creative, but we start to know enough about how well complement and what I say, species that complement each other, how they function in the system so that we can maybe start to be more creative. And we need to foster creative disturbance. We should not just go and try to replicate the disturbance that occurred in the past, but maybe to create new kind of disturbance that will facilitate, accelerate the self-organization and the adaptation. And of course, as I mentioned, we need to integrate risk, flexibility, adaptability to get an optimal yield of all the various goods and services. So that's what I propose this name, dynamic complexity-based forestry. I hope this will be teach You will taught this in the next few years in the Faculty of Forestry and other places in the world. So 2 conclusions. The complex adaptive system, as I see it, and I'm willing to be challenged, and this is very important. If you convince me tonight, tomorrow I start working on this, because I don't want to be stuck in believing in what I believe today so badly that I'm not open to new ideas. I'm open. I can change. But I believe that it provides a framework that can incorporate a lot of the ecological knowledge that often in forestry we don't consider, and the social science, into novel management practices that will be better adapted to the rapidly changing conditions of the future. And I think that we can start by looking at these 7 characteristics of complex adaptive system, look at what we do today, and maybe look at what is missing in terms of these properties, and maybe make some changes or some modifications. So we don't need to invent something totally new. I'm not proposing something totally new. I'm proposing some adaptation. And I've been working on many examples of this, and I have some paper coming out. I can send it to you, but we've tried to do this. Thank you. So questions, comments?
We have 2 microphones, one over there.
Tomatoes, I like tomatoes. Eggs, a bit less.
Hello, Christian. It was very good to hear your talk.
How are you?
Very well, thank you. So I have a question for you. What role do you see exotic species being used in attempting to create new mixes that we do not currently have on the landscape?
Yeah, I'm not totally against exotic species. I'm using them, I'm testing them. I think they could play a role in intensive forestry to produce a lot of timbers. They can also play a role in replacing some species we are losing. I'm thinking about the ashes that we are losing in eastern Canada, and I think we may want to have exotic species, and I think we maybe need exotic species because they have some functional traits that are important to make the system more adaptable. I think we have to be careful. I'm not saying let's bring all kinds of species and mix. Let's be careful. Let's think about what are the challenges we are facing in the future, what is likely to arrive, what kind of set of traits we need if what we predict happen, what kind of traits are missing in some system, and maybe, yes, to bring some exotic species. I know it's an outrageous view that some people don't like, but as I said, maybe we don't have a choice. 10 years ago, I would have said, no way, you're crazy. But now, I'm not totally against it, and I think it could play a role.
Just one more question, totally off topic, I guess, but in oil sands production, you talk about stability hypotheses, and we're converting upland boreal forest into tailings ponds, for example. What role do you see your approach in dealing with a disturbance that is so, so like a glacier coming through or something? It's very destructive in some ways.
What is destructive?
Pardon?
What is destructive? You said something is very destructive?
Well, I'm just saying, like turning upland forest into a tailings pond.
Yeah.
What would you do? You just say you give it up, or do you work on it using your approach?
I think it's a good example of using the approach. What are the challenges you have there? What you need to have in the system so that it can deal with these challenges and try to have the right mix to deal with this. I think this is the right approach. We did something similar in central Quebec, where it was mainly private forests, but people were asking, what should we do to prepare ourselves to the future? And we look at the species, the connectivity, the modularity. We played with some scenarios of climate change, some possible insects that will come, and we came up with a plan of plantations of different species to increase connectivity, maintaining modularity, and bringing some traits that are more likely to do well if what we predict will arrive. If it doesn't arrive, it doesn't matter. We have the other species also. So it's this idea of adaptability that is very important.
Hi, Christian. Wonderful talk. Some great thoughts, some great ideas that I hope the students and the rest of us will take away today. But there's a lot of fear and paralysis about moving into this new ground. How do we overcome the inertia and the paralysis that's out there that you mentioned is reflected in government policy? And it's largely based on the fear of moving things in a way that's going to cause some damage or be a problem. How do we get over that?
I'd like to say talking to them, sitting with them, explaining to them. But my experience is, and you won't like this, two things. We fire all of them and replace it with new people. That will work, I think. Not easy to do, but that will work. The other way will be that we need a crisis. And I would give an example. In Quebec, we had this movie, The Boreal Mistake, or Error Boreal, big shock. And it needed this to change the direction we were going. And I actually showed the movie to my students 3 weeks ago. And I was surprised. I said, this movie has not aged very well. It's not relevant anymore, which was great. It did what it had to do to change the direction. So it needed a shock like this. So we need a shock. And I will not, I'm crazy, but not crazy enough to think that I am the one that will give the shock. I'm trying to provide the ideas. I don't know. We need a big singer or someone, I don't know, charismatic that will do a movie or something. We need a shock, or maybe we need a big forest to collapse. And I say this because, again, I had David Lindenbyers, who works on collapsing forests in Australia. It was very interesting for me. And we talk a lot, and we're working on a paper. Of course, he has written 600 papers in the last 20 years. So for him, just a little aside, it's interesting. For him, you sit one evening and you write a paper. It's an interesting concept. We'll try to do this. But the paper is half done. Anyway, but collapsing, we need a collapse. I want a collapse. I want a forest that collapses. A bit like the pine beetle, maybe. We need collapse that people will say we need to do things differently. Like I'm working in urban forestry. My colleague Dan Nisha and I went to see the city of Montreal. We say, you know, you have a lot of ashes. There is this bugs killing trees. It will come here in the next 5 years. We should do something. They said, we don't have money. No. Now it's there killing trees. They say, hey, what can we do, please? I don't know what to do.
Thank you.
Hi, Christian.
We talk a lot about you, Stan, with David Lindenbyers, by the way.
Oh, you do?
Yeah.
My ears are burning.
And he says, say hello to Stan if you see him. So hello.
To him for me, too. So it seems to me that the key take-home, or at least what I got out of the talk, was the only way to deal with uncertainty is to diversify your portfolio.
Yeah.
So I guess that's a reasonable, simple way to proceed.
But I will add something. Diversified in an intelligent way.
Well,
thinking about,
how can you do that if there are so many unknowns?
Well, I know, but there are some knowns. At least we should deal with the knowns. And of course, plan for the unknown, but there are knowns. We know climate change is there. We know about a lot of the invasive species and a lot of the disease coming. We know a lot of stuff. But there's a lot of unknowns. And diversifying in a way that creates more diversity of possibilities of response to these unknowns, yes, I think this is the way. And this is, and I will insist, because Simon Levine has insisted a lot on this modularity concept, which probably, but you also create landscape that can facilitate connectivity, but also can break some of the spread of some of the problem also, so some modularity. I think that you have to work at different levels.
Yeah, so that's a great start in the sense that all things are good in moderation.
Yeah.
But that's not much of a guide to a forest manager or to companies that are attempting to continue to stay viable Don't they need more guidance in that regard as to how to do that in terms of the proportions of these different approaches? That's where the rub will come in. And I sort of perceive your talk indicates to me we don't know enough about this system to give them any guidance there yet.
Well, I will say outrageous things, and maybe I won't come out alive here, but I don't think that forest companies that needs one single tree should be the group managing the forests. I don't think so. I don't think so. I mean, poor foresters, they are there, they say, I would like to manage for all of this, but I need to bring this kind of species and wood. I mean, it's a very difficult task. And I say this, and in Quebec, we've changed, you know, and I look at what the government is doing, and they are not doing very well. So I almost regret the good old days when I could go and see a forester in a company, and they would be able to change very quickly what they were doing. So I know this, and when you deal with a government, it's almost impossible to change things. I see the two conflict, but my message is you cannot manage a forest for one single species or one single good. It's for all of the goods. And I know that the forest companies want to have the cheapest wood for the next 30 years. I know that. So how can we ask them to do this, what I propose? I don't know. Maybe it's possible. Convince me it's possible. I'm willing, because I admire the ability of forest companies to turn around and do things very differently, much better maybe than government. Now I make enemies everywhere, but it's not easy.
Hello, bonjour, Dr. Messier. I'm way over here in the dark. I'm just wondering about a practice which does not encourage biodiversity in our new spruce forests. Apparently under a free-to-grow policy in July, many of these young spruce forests are sprayed with Roundup. Active ingredient is glyphosate, which has been shown to kill frogs and generally be even bad for human digestion, etc. I'm just wondering, what is the policy in Quebec, which seems to be a little more forward-thinking in terms of not using pesticides?
Now you got me. Because I used to think that we should not use herbicide, it's better, but often the alternatives to herbicide is even worse. We go out there in the forest and we have these machines and we scarify often 3 or 4 times to kill as many weeds as possible. And then we plant trees, and then we ask these poor people to go and walk with these machines that release a lot of oil in the environment and even to their health to cut the competing trees. So is it better than using herbicide once? You know, I mean, I try to be as neutral as possible. I'm not sure. And we've done some experiment that instead of using herbicide everywhere with hybrid poplar, we use herbicide only 1 meter around the trees, and it had exactly the same impact in terms of increased growth without destroying a lot of the understory species that we do when we scarified a lot. So there kind of may be ways to do things differently. I think it's dangerous to think this is good or bad. Sometimes the alternative is, you know, a lot of people, I had a German, Jürgen Bauhaus, you know, he's from Freiburg, and he gave a beautiful talk showing that a lot of environmentalists in Germany would like to protect the forest and not cut the trees. And he made some very good argument that if we don't cut the forest to build houses and we use cement or steel, it will be even worse in terms of climate change, energy and CO2, etc. So I think we have to be careful. I think we always have to, but I think one question is, do we need to eliminate all of these competing species? We should plant mixed species anyway, species that can complement each other and might actually produce more on the long term. So I think that's maybe a better question than just say, how do we make the spruce grow better? Maybe we should not use only spruce.
Merci beaucoup.
Yeah, I just want to note that you did piss one more person off by blaming the worldwide plantation forestry on the Germans. But anyway, so...
It was much worse than this. It was the whole forestry, but anyway. Yeah. And I go and work with, Germans, and they tolerate me.
No,
so
I'm just kidding.
It's okay.
That's good. No, my question is, correct me if I'm wrong, but you know, the triad approach, is that not something that also came out of your shop?
Yeah, and I had a workshop, 2 days workshop, just before coming here.
I see. Oh, yeah.
Showing what is the state of this project after 10 years.
Yeah. Because that has an element of simplicity and highly controllable silviculture, no?
No.
At the end of very intensive production forestry?
Well, we allocate a portion of the forest for very intensive forestry, of course, but we are promoting mixed species plantation instead of monocultures. That's very important. We accept that maybe we need exotic species because they will be producing more or even better adapted. So a lot of the elements I talked about, but of course when I'm talking about intensive, this is a place where humans will intervene. So you have more possibilities when you know you have to intervene. People have made calculation, and I think it's the same here. You could make more money by doing intensive forestry than by doing extensive forestry, especially in Quebec, where we go sometimes almost 1,000 kilometers north to cut trees that are big like this. And then we are forced to replant because it doesn't regenerate and it costs a lot of money. So, but, and the plan with these plantations, and I've told that to the foresters, and I say, I want plantations that if in 10 years something happened and everything disappears, these forests will be able to regenerate and grow and be a productive forest, to not do like the Japanese. To me, that's important. So it's, yes, we want to produce a lot of timber. By mixing species, we can produce as much, or in some cases more, fiber. We have less risk of disease, and let's say one species get wiped out. If you have 2 other species in the plantation, at least you will produce something. And we want these trees with the traits that will allow this forest to regenerate and be self-adapted, even if we stop going there. So these are the elements. So you're right, when I started the triad, I was not thinking complexity, but we've changed a lot of the things in the triad as we go along. And we're allowed to do it because we have the permission of the government to do things in this 1 million hectares that are outside the law. They still allow us to do this. They say this is an experiment. Please do it. Now they cut most of the funding to do what we want to do, so maybe it's a way to tell us we're not happy with what you do, but government change and funding will come back, so it's okay.
Well, anyway, let me still try to argue the German side of this.
Please. Please do.
You know, because I think one of the last slides that you had there was on controllability and uncertainty. Yeah. But if you're in that lower left corner, those systems might actually be really quite simple, and because there's short rotation, there's also not that much uncertainty. Yeah. So I'm thinking there is still a role for those simple systems on that very bottom of your
Of course, the shorter the rotation, the less uncertainty you have. And maybe the more you can do. You're right. I don't deny that, for sure. But I mean, it will be difficult here. I mean, I talked to you, you said maybe you can do something in 20 years. 20 years is short, but a lot of things could happen in 20 years.
Yeah, you're quite right.
There's one thing that cannot happen in 20 years is the Maple Leaf win the Stanley Cup, but a lot of things could happen. I had to throw this.
No, that's good. Yeah. No, you're right. I mean, especially, I would say temperate and boreal forest ecosystems that may not, you may be right.
But yeah, the shorter you do the rotation, maybe the more risk you can take. So there is some kind of a gradient, but you could maybe mix things also. I'm a big fan of course, mixtures of species to reduce the risk, create better habitats, make the forest even more self-adaptable and even socially more acceptable. We did some tests in the triad. In a lot of our intensive areas, people were saying we don't want plantations. What they meant is we don't want monocultures. Because when we show them plantation of many species, they say it's okay. So they didn't want these monocultures. I don't know why. But I think it's because the forest where we are is very diverse. There's many species, and they are not used to walk in a forest where there's only one species. So it's more of a experience. They don't have this experience of, and they don't like it.
Christian, bankers and Germans might be in the same category of having a very simple approach to life, in that they like to have things that are very predictable.
Bankers. Okay.
So if you were somebody who wanted to invest in forestry, convince me that you should abandon the sustained yield approach the way we're currently doing it, and go to the novel approach that you're proposing.
I have a more radical solution. Bankers screwed up the world a few years ago. They screwed up the world. I think we should get rid of them. They have the wrong, no, but I'm serious. They have the wrong approach. Look what happened. They created one of the worst economic crises on the planet. These are the same bankers that you say that I have to convince to, no, I think we should change. And by that, what I mean is convincing, that was one of the things, we need to change the way we function. We should invest in all the goods and services, looking at all the services and maybe bankers are not the best one to invest there. It's a government maybe that should do this. That sounds socialist, but I'm from Quebec, so that you understand. But no, don't talk to me about bankers. I'm very upset about bankers. No. I hope there's no bankers here, eh?
Any questions or more? If not, we'd like to say let's give another round of applause for the speaker and for our generous donors.